Hey folks, Mr. Dell here. We are looking at a problem that has us do some graphing of a scatter plot and then interpreting that scatter plot. So this is coming from CPM. This is course 3, and this is from chapter 9 closure, specifically 9-162. So it says Sarah loves to order paperback mystery books. Some of her recent orders are shown in the table below. So one of the orders was she ordered one book at a total of $10.25, and then three books at $18, one book at $10.25, another order of four at each of those. So these are the number of books she ordered and the cost when she did that order. So first, let's make a scatter plot. So we got to decide which is going to be my vertical axes and which is going to be my horizontal axes. Let me get this lifted up a little bit here so we can see the graph and the table. Okay, so I'm gonna this is going to be the number of books, right, is my dependent variable, and the total cost is dependent upon that. So independent variables, wait, let me rephrase that. Number of books is the independent variable, total cost is dependent because the cost is dependent upon how many books. So we're going to put the number of books down here on my x-axis, on my horizontal axis, number of books. And then we'll put the total cost on my y-axis, total cost, and that's in dollars. So if I think about where I'm at with my numbers, I can go by ones. I'm going to actually make this 1, this 2. I'm going to skip a few, 3, 4, 5, and 6. And then my money, I got to get up to $26. So if I go 10, 20, 30, I can do that. So let's do that. So this will be 10, 20, and then 30 and 40 up here. Okay. And that's in dollars. So each of these, by the way, each of these lines here then are by 2, 4, 6, 8, 10, right? 12, so on and so forth by twos. So let's graph what we've got. So at one book, it was 10.25. So 10, a little bit more, 25. At two books, do I have two? Actually, let me go one at a time. So I did this one at three books. It's at 18. So this is at 20. So 18 would be two below that. At one book, again, I still have the same point. So I just put the same point on it. At four books, it's at 21. So 21.75. This is 22 right here. So I'm going to go just a tiny bit below that. And at two books, it's 14. So 2 would be 14, which is, let's see, this is 12. 14 would be right here. And at 5, let's see, do I have 5 books? Yeah, 5 books is 26. So this is 20, 22, 24, 26, and a little bit more than that. So we'll put it right there. So there's my plot. Now it says fully describe the association. So we want to know its form, its direction, its association, and outliers, etc. So if we think about form, this is a linear, right? It's linear. And so form, I'll just do one at a time and then we'll write it all out. That's linear. It's either linear or nonlinear is how we're going to put it for our class. You could also say cubic or quadratic when you start to get into other function forms. Linear, nonlinear, direction, usually it's either positive, okay, or it's negative if it's decreasing, so it's increasing or decreasing, right? Positive or negative, increasing, decreasing, you could say that. And then this one, association, is it strong? Is the pattern strong or is it weak? Okay. Or moderate. Outliers would be points that don't fit the pattern. That's what outliers are, points that don't fit pattern. So let's take care of this for this problem. So first of all, I can see it's going to be linear, right? That looks very much like it's growing at a linear growth rate, and it's positive because it's in a positive direction, so it's increasing. And strong because that's pretty close together to be a nice line. So I'd say strong, and there's no outliers. Okay, so we're going to say it's a strong. I'm going to put my adjective for a strong, positive linear association with no outliers. Okay, so that's how we will describe this association. Now it says to draw and determine equation of best fit. Now remember, when you're doing an equation of or drawing a line of best fit, we want to connect a couple points that we have that are reasonable, that we can get a good slope from. So if I look at where 2 is at 14. So this is at 2 comma 14. So that's a nice point. And then if I think of 318, if I can connect those, would that stay? Or maybe even here at 526, we could look at that. I might actually maybe, let me see if I can figure out what would make sense if I connect those two versus the 2 there. Yeah, probably. I can probably get away with doing that. I'm going to use these 2 points in my equation, in my line, so that way I can get the slope here pretty nicely. So if I use those points, this one was 318. So 318. So if I'm determining this equation of line of best fit, let's see, I might have to get this a little higher even. Line of best fit here. Remember, your equation's always in y equals mx plus b if it's linear, and this is linear, and m is your slope, right? So that's your slope, and b is your y-intercept. So we can figure out a slope based on the 2 points that I chose to go through. So remember, if we do a slope triangle here, my change in y is the rise. That's 4, because I went by 2's each time. That's 4, and my change in x from 2 to 3 is just 1. So this is going, so I would say so far I could say my equation is y is equal to 4x, because that's my slope is 4 over 1, and then plus, what would be my b? Well, where does this look like it's crossing? To me, it kind of looks like it's hitting at 6. So it's at 6 it would go through, so I'm going to say plus 6. So this is one possible line of best fit. Okay, there's other ones if you pick the different points to go through, but I think that's a nice one there. So then, based on this equation, estimate the total cost of an order of 10 books. So remember, what number of books is x? That's my x. Total cost is my y. So I can say I'm going to plug 10 in place of the x. So y is equal to 4 times 10 plus 6, which is 40, plus 6, which is 46. So if x equals 10, y equals 46. So 10 books cost approximately, based on my line of best fit, $46. Okay, there we go.